Alright guys, good morning. Welcome to Math 0410 Elementary Algebra. This is lecture 11. This is your professor, Mr. Pacheco. Today's date is November 22nd of 2021. We are starting our chapter 12 lecture. This is our final chapter of the semester, guys, so let's go ahead and finish off. There are going to be six sections in total. This presentation is going to cover the first half of chapter 12. So this first one is 12.1 exponents. Make sure you pause along this video when you need to keep writing if you need more time. This is the do-it-yourself phase, so pausing and rewinding are going to be your best friends this morning with this video. Okay. The first thing we're going to go ahead and talk about is the product rule for exponents, guys. So that means if m and n are positive integers and a is a real number, then when we have a to the m times a to the n equals a to the m plus n, so we would be adding the exponents and we just keep the common base. A doesn't get messed with at all. Like for example, so helpful hint. Don't forget that 3 to the 5th times 3 to the 7th. We do not multiply 3 and 3 to get 9. No. We have to keep it. Right here we didn't keep it. So it has to stay as 3. So we have 5 factors of 3 times 7 factors of 3. So, and in total we have how many 3's? 12, not 9. So it'll be 3 to the 12th power. The base is the same, and we just added the exponents 5 plus 7. So make sure you write this helpful hint as well, guys, just so you can avoid any mistakes when we start using these laws of exponents. So this was the product rule. So that's how do we apply the product rule? So we know we add the exponents. So here, use the product rule to simplify. Look at A. We have 4 squared times 4 to the 5th, and so on. So I'm going to go ahead and work on A first. A is 4 squared times 4 to the 5th. So the base is just 4, but we're adding the exponents. So it'll be 2 plus 5. 2 plus 5 is 7, so it'll be 4 to the 7th power. You can plug that into your calculator if you wanted to. And we can move on. So B. B is x to the 4th times x to the 6th. The same base as x's, so we keep the base there. And then we add the exponents. 4 plus 6, which is 10. So the answer is x to the 10th. This is the most simplified we can go. C. You have y to the 3rd times y. When you have a letter by itself, guys, remember there's an invisible 1 there, so it's y to the 1. So that's the same base, right? The y. So we have the y, and then we add the exponents. 3 plus 1, which is just 4. Y to the 4th. So let's go ahead and move on to D. D, we have 3 y's. We have y to the 3rd times y squared times y to the 7th. So we'll just go ahead and multiply from left to right. So we're going to do y to the 3 plus 2 times y to the 7th, which is y to the 5 times y to the 7. I'm just pretty much doing the rule one at a time, but we know we would have just added all of these across, which would have just been 12 in total. But I'm just doing the product rule one at a time. So I did these two first and got this one, and then I finally did both of these here. Alright, E. Negative 5 to the 7 times negative 5 to the 8th power. So that's going to be negative 5 is the base, but we're going to add the 7 and the 8, which is 15. to the 15th power. And then we have f. F, you have a squared times b squared, which is just a squared times b squared. We do not add them because we do not have the same base. So since it's a and b are two different letters, we do not add the exponents, guys. We just rewrite them the way it is because that's the most simplified we can do. Try to overthink this property, guys. If you have the same base multiplying, we just add the exponents. Okay, add the exponents. All right, now you give it a try. Here's the practice problem. Remember, use the product rule to simplify. I'm going to go ahead and just work straight through it. Make sure you pause if you're trying this. Do it yourself and then check your work with mine at the end. So A. So that's going to be 3 to the 4 times 3 to the 6. That's the same base, alright? The base is the same. But the 4 and the 6 are added because the product rule applies. And it's 3 to the 10th power. We're done with A. B. You have y cubed times y squared. Go ahead and, since same base, add the exponents. 3 plus 2 is just y to the 5th. C. Z times z to the 4th. Remember, this has an invisible 1. Same base, guys, z. So we just add the 1 plus 4. So we get z to the 5th power. D. It's x cubed times x squared times x to the 6. We know we're just going to add the exponents. 3 plus 2 plus 6, which is just 11. Negative 2 to the 5th times negative 2 to the 3rd. So negative 2 is the base, and then we just add the exponents. So then it'll be negative 2 to the 8th power. And then F, we have b cubed times t to the 5th. Those are different bases, so we cannot add the exponents, so we just rewrite them as is, and we are done with F. Try not to overthink these problems, guys. Remember, product rule, same base, add the exponents. Same base, add the exponents. Now here it's different because now we have numbers in front of the letters too. So we have to look at A. So use the product rule to simplify. So A says 2x squared times negative 3x to the 5th. So we know we're going to add the x's, right? The exponents, the 2 and the 5. But the numbers, there's still numbers being multiplied. So we have to multiply 2 times negative 3. So what does that look like, right? So 2x squared is just 2 times x, right? Whereas the second term, negative 3x to the 5th, is just negative 3 times x times x times x 5 times, right? So let's multiply the 2 times the 3. 2 times negative 3 is negative 6. And then look how many x's we have. 1, 2, 3, 4, 5, 6, 7. So it's x to the 7th, and we're done. So just remember, what did we do here? We multiplied 2 times negative 3. This gives us negative 6. And then we had x squared times x to the 5th, which is just x to the 2 plus 5, which is just the 7th. That's where that comes from. So remember, multiply the numbers in front, add the exponents. So look at B. B has x squared times x cubed, y times y squared. So I'm going to combine the x's together, right? So we have x squared times x cubed, then we have y times y squared. Well, add the exponents, right? So it'll be 2 plus 3 for the x's, and for the y's it'll be 1 plus 2. It's an invisible 1. So then we get x to the 5th times y to the 3rd, and we're done. Just because there's no numbers in front of the x. Let's look at C. So C, we have a -1 invisible that we don't see in front of the A. So here we're going to multiply for the numbers. So I'm going to put the numbers apart, right? So I'm going to pull -1 times a +3. I'm going to do A to the 7 times A, and then B to the 4th times B to the 9th. So -1 times 3 is -3. Then for the A's, it'll be 7 plus 1. For the B's, it'll be 4 plus 9. Because we're a product rule. So -3, A to the 8, B to the 13th. And we're done. So this product means to multiply. So we're not doing any new concepts in this examples, guys. We're just multiplying the numbers and then we're adding the exponents, keeping the same basis. So rewatch these examples if you need to see more examples play through it. Look at this practice problem. Use a product rule to simplify. Pause it here to give it a shot on your own before I start working it out. A. So remember, I'm going to pull the numbers together and then the letters stay together. So it'll be -5 times -3. Then we have y to the 3rd times y to the 4th. So multiply the two numbers. -5 times -3 is a +15. And then we have y to the 3rd plus 4, which is just y to the 7th. And we're done. For B, we have y to the 7th times z cubed times y to the 5th, z cubed times z. So it'll be y to the 7th times y to the 5th times z cubed times z. So add your exponents, 7 plus 5, and then z 3 plus 1. So then we get y to the 12 times z to the 4th. And we are done with B. This is a -1 invisible that we don't see. The m, it's its own thing, and then we have the n as well. So they're very separated. So we have -1 times the 7, right? Then we have m to the 4th times m, and then we have n to the 4th times n to the 10th power. So multiply -1 times 7 is a -7. M, and then this is a 4 plus 1. We have an n, 4 plus 10. So then we have -7 times m to the 5th times n to the 14th. And we're done with this practice problem. Make sure you're just looking at the problem and doing what it's asking to do. Don't overthink it. Don't overwork it. If m, so now we have a new rule to look at. So the first rule we learned was product rule. Now we're going to learn the power rule. So power rule is if m and n are positive integers and a is a real number, then when we do a to the m to the n power is m times n. We're going to multiply the exponents and we keep the common base. Okay? So look at this example. Use a power rule to simplify. Y to the 8th to the 2nd power. That's going to be the same thing as y to the 8th times 2. We're going to multiply 8 times 2. 8 times 2 is 16. So then that's the final answer. Y to the 16th. Because we multiplied the exponents. Okay? Look at B. My base is 8. But the 4 to the 5th power of the 5th, we're going to multiply those two. 4 times 5 is 20. So B is 8 to the 20th power. Now we have C. negative 5 to the third power, but that's also to the seventh power. So we're going to do negative 5 to the third times 7, which simplifies to negative 5 to the 21 power. And we're done here. So that is how you apply the power rule. And that's when you have a power to a power, guys. A power to a power. Here are these practice problems for you to give it a shot. Use the power rule to simplify. Pause here to give it a shot. Go ahead and do the work. Show you the answers. So A, we have A is z to the third to the seventh power. So z is the base, but we're going to go ahead and multiply 3 times 7 to get z to the 21st power. And we're done. B, we have 4 to the ninth power squared, which the base is 4, but we have to multiply 9 and 2, so we get 4 to the 18th power. C, we get negative 2 cubed to the 5th power. So then at that point, the base stays negative 2, but we multiply the two exponents 3 times 5. So then we get negative 2 to the 15th power, and we're done. So the power rule isn't that much difficult. We just multiply the exponents rather than add them. So keep that in mind, guys, as we move on, because you're learning the different laws in this lesson. And there's a handful of them. So make sure you remember. Product rule, multiply the numbers in front, add the exponent. Power rule is you multiply the two exponents. The power to a power is multiply. Here's this helpful hint. So take a moment to make sure that you understand when to apply the product rule and when to apply the power rule. So product is when you have two things being multiplied, and then power rule is when you have a power to a power. Okay? So take your time to write this helpful hint, guys. Make sure you pause it here. Alright, I'm going to move on. So now the power of a product rule. What does that mean? So if n, so the power of a product rule. So if n is a positive integer and a and b are real numbers, then if we have a and b to the n power, then the exponent gets distributed to everything inside the parentheses. So look at a. We have st to the fourth power. So that tells us that everything in here is going to get the same exponent. So st to the fourth power. So that means it's going to equal to s to the fourth power times t to the fourth power. And we cannot simplify anymore, so that's the lowest we can go. We're done. And another way to look at it, st to the fourth power, that's just st times st times st times st. And we get s times s times s times s, which is just s to the fourth, and t times t times t times t, which is t to the fourth. So it would have given us the same answer, but I just didn't want you to have to worry to write this down. You could do that though. That's the way that you read this. So 2a to the third, we know that it's going to be 2a times 2a times 2a. But we want to do the shortcut, right? We know that means if we have 2a to the third power, that's just going to be 2 cubed times a cubed. Well, 2 cubed is 2 times 2 times 2, which is just 8. And then a cubed is just a to the third. And we're done. So now we're at C. So C is 1/3 mn cubed to the second power. So that means each of these things inside the parentheses is going to get this squared. So that means we're going to get 1/3 squared. Then we're going to get m squared. And then we're going to get n cubed squared. Okay, because right, the squared goes to all the things inside the parentheses. 1/3 squared. So when you're powering in a fraction, guys, pretty much the top gets the power and the bottom gets the power. So we're going to have 1 squared over 3 squared for this part. Then for the second parentheses, m squared, n times m is just m squared. And here we have 3 times 2, so this will be 2 times 1, right? Because there's a 1 right here. And then we have n 3 times 2, because we're multiplying the two exponents. Well, 1 squared over 3 squared is just 1 over 9 times m squared times n to the 6. And we're done. Alright. So then we're going to go ahead and distribute this square to all the things here, the 5, the 2, the 3, and the 1. So these both have a 1. So then it'll be negative 5 squared, x squared to the second power, y third to the second power, and then z to the second power. So negative 5 squared is negative 5 times negative 5, which is a positive 25. I'm going to multiply the 2's here, right? Because it's a power to a power. The 3 and the 2, and then the 1 and 2. The 1 here. So it'll be x to the 2 times 2, y to the 3 times 2, and z to the 1 times 2. So then we get 25x to the 4th, y to the 6th, and z to the 2nd. And we are done. Very important that you follow the power of a product rule. You're following the correct powers, guys. There's more than one way to look at this. You just utilize the one that best suits you guys. You can expand it out, write how many parentheses it should be, and then simplify by just adding the letters or whatever. It's up to you how you want to do this. It's just, use your math facts to break these problems down. Here are some more practice problems, guys. Simplify each expression using the rules that we've learned so far. So look at A. So then we have PR to the 5th. So we're going to go ahead and distribute this 5 to the P and to the R. So then we're going to get P to the 5th times R to the 5th. And we're done. B, we get 6B squared. So then the 2 goes to the 6 and to the B. So then we get 6 squared times B squared. Well, 6 squared is just 36. Bring down the B squared, and we're done there. We have C is 1/4 x squared times y to the 3rd. So then the 3rd goes to the 1/4. So it'll be 1/4 to the 3rd power. Then it'll be x squared to the 3rd power, and then y to the 3rd power. Well, 1/4 cube is just 1 cube over 4 cube. X squared to the cube power is just 2 times 3. And we have y to the 1 times 3. So 1 is just 1 cube is 1. 4 cube is 64. X squared times 3 is 6. 1 times 3 is 3. And we're done for C. D is negative 3, A to the 3rd, B to the 4th, C to the 4th power. That gets distributed with everything. So then we get negative 3 to the 4th, A to the 3rd times to the 4th, B to the 4th to the 4th, and this C to the 4th. And there's a 1 here. So negative 3 times negative 3 is a 9. So it'll be positive 81. 3 times 4. 4 times 4. 1 times 4. So then we get 81a to the 12th, b to the 16th, c to the 4th power. And we are done with this practice problem. Try not to overthink this, guys. It's pretty much the main setup here. Um, we have the power of a quotient rule. If n is a positive integer and a and c are real numbers, then a over c to the n power is an over c to the n. So which is what I was saying earlier, when you have a fraction to the exponent power, you just give the top the same exponent and the bottom the same exponent. But keep in mind, the bottom of the fraction cannot be 0, because we cannot divide by 0. So look at this example, m over n. So we're going to do 7 to the m, 7 to the n. So that's equal to m to the 7th power over n to the 7th power. And we're done. This b is very similar as well. So now we get, but now the top has a exponent already. So it's going to be a power to a power. And then we're going to do 3y to the 5th to the 4th power as well. So the top part is easy. We're just going to multiply the 3 and the 4. Right? 3 times 4. The bottom, though, we have the 4 here, but there's a 3 and a y. So the 3 gets the 4, and then the y and the 5 gets the 4 as well. So we're multiplying it here and here. We're not multiplying, but we're applying the power rule. So 3 times 4 for the top is 12, x to the 12 over 3 to the 4th, guys, is 81. Y to the 5 times 4 is y over 20. And we're done. So this is a power to a power, and then the quotient rule, which is if you're applying a power to a fraction, then the whole fraction gets the power rule. Here is another practice problems. Simplify each expression, guys. Pause here to try them on your own. So let's take a look at A. So it'll be x over y squared to the 5th power. So that means we're going to put the 5th to the top and around the y squared. But x to the 5th is just x to the 5th, right? Because it's a 1 times 5. Here we have 2 times 5, right? Power to a power, we multiply. So then we get x to the 5th over y 10th. And we're done with A. B is much more complicated because now we have multiple variables and stuff on the terms. So we're going to do it to the top, right? So it'll be 2a to the 4th to the 5th power over b to the 3rd to the 5th power. Well, we know here on the top, the 5 is going to go to the 2 and the a. So then we're going to get 2 to the 5th times a to the 4th times 5. And then the b is going to be 3 times 5. So we're multiplying that ahead. So 2 to the 5th is 2 times 2, which is 4, times 2, which is 8, times 2, which is 16, times 2, which is 32, a to the 20th over b to the 15th. So we're multiplying 4 and 5 and 3 and 5. Okay? Now, the quotient rule. The quotient rule for exponents. If m and n are positive integers and a is a real number, then when we have a to the m over a to the n equals a to the m minus n, as long as a is not 0. So when we're dividing the same base, like the x, the 4, the negative 3, when we have the same base, we're subtracting the exponents. So let me show how that looks like. So x to the 5th over x squared, right? So we have m is 5, 2 is n. So we'll do 5 minus 2, which we know is 3. So x to the 3, right? We know that's the answer. But why? Well, x to the 5th means there's just 5 x's on top, right? And then the bottom means x squared means there's 2 x's on the bottom. So in math, when we have something on top and bottom, that's just a 1. That's just a 1. So we're left with these 3 x's, so the answer is x cubed. That is the answer. But now this is the expansion way to see it. This helps you visually see what happens to the laws. So you can just subtract them. But we know the rule is just 5 minus 2, right? The top minus the bottom. 5 minus 2, which is just 3, which is the same answer here. So you can not overthink it, guys. The quotient rule is pretty cool to apply. B, you have 4 to the 7th over 4 cubed. So expanded form, you'll see 4 sevens on top. 1, 2, 3, 4, 5, 6, 7 over 3 4s on the bottom. Cancel out 3 of them. We're left with 4 to the 4th power. And we're done. Which is the same thing as 7 minus 3. Since we know the formula works, I'm just going to go ahead and stick to the formula. So then for C, we have negative 3 to the 5 minus 2, which is just negative 3 to the 3rd power. So we subtracted 5 minus 2. Notice in D, it stays the same because we cannot subtract these two since they are different bases. So we're done with D. Now for E, we have the 2, right? The 2 stays there. But remember, we have X, right? We have a 1 and a 1 on these X and Y. So it'll be X to the 5 minus 1. And then a 2 minus 1. Since this is the top, bottom. So then we get 2 to the x4 times y to the 1, which is just y. That is how we apply the quotient rule, ladies and gentlemen, the quotient rule. Here are these practice problems, guys. Simplify each quotient. So you are going to have to use the quotient rule here, ladies and gentlemen. I'm going to go ahead and show you. Remember, if it's the same base, you subtract the exponent. So A, we have z to the 8 over z to the 4th. So that's going to be z to the 8 minus 4, which is just z to the 4th. And you're done. B, we have the base to be negative 5 to the 5th over negative 5 to the 3rd. The base is negative 5, but we're doing 5 minus 3, which is just negative 5 squared, which we could probably take another step and get 25. C is 8 to the 8 over 8 to the 6. Same base, right? We have A, but we're going to do 8 minus 6, right? Which is just 2. 8 squared, which is just 64. D, it just stays 2 to the q to the 5th t squared because they're different letters. We cannot subtract them. But then E, we have 6x cubed y to the 7th over x y to the 5th. So the 6 stays the same, right? But the x, what are we subtracting? We have 3 over 1, so it'll be 3 minus 1. The y will be 7 minus 5, right? The top minus the bottom. The top minus the bottom. So we go ahead and get equals to 6x squared y squared, and we're done. Try not to overthink these practice problems, guys. Apply the quotient rule as best you can. Subtract the exponents. Divide the numbers if there is numbers to divide. Okay. Z exponent. As long as A is not 0 or any variables inside is not 0, you're good. So look at A. 3 to the 0, that's just 1. B, all of this to the 0 power, 1. Negative 5 in parentheses to 0 power is 1. D is negative 5 to the 0. So that means we have to do negative parentheses 5 to the 0. We know 5 to the 0 is 1. Negative times 1 is just negative 1. A fraction to the 0, so it's just 3 to the 0 over 100 to the 0, which is just 1 over 1, which is just 1. Here is 4x0, so that's going to be 4 times x to the 0, which is just 4 times 1, which is just 4. So now you know the different ways you can get to the 0 power, which one gives you a positive one, which one gives you a negative one. Parentheses matters. Here are these practice problems on simplifying each expression. We have negative 3 to the 0, no parentheses, so we know that's going to be a negative times a 1, which is just negative 1. B is negative 3 to the 0, which is just equal to 1. C is this 8 to the 0, which is just equal to 1. D is 0.2 to the 0, which is just equal to 1. E is just 7a squared y to the 4th to the 0 power is just equal to 1. F is 7 times y to the 0, which is 7 times 1, which is just 7. So go ahead and now we're going to use any rules that we know to simplify any exponential expressions. So look at A, x to the 7 times x to the 4. And right there we know we're multiplying, so that's going to be adding the exponent, 7 plus 4. In case you didn't know that, you can just expand it. So we have 7x's here. So 1, 2, 3, 4, 5, 6, 7. Then we have 4 more. 1, 2, 3, 4. Add them all up. So then we get 7 plus 4, which is just 11. We're done. So B, we have a fraction to the exponent power. So the 4 can go to the t and to the 2. So then we get t to the 4th over 2 to the 4th, which is just t to the 4th over 16. And we're done. And then C is just 9y to the 5th squared. So we're just multiplying these two together. But if you want, you can just distribute the 2 to the 5 and the 9. By distribute, you're just applying the power. You're not really multiplying it. So forget that I said distribute. So 9 5 to the squared. So that means we're doing 9 squared times y 5th squared. So that's power to a power. So we have to multiply those, right? 9 squared is just 81. Y to the 5th is y to the 5 times 2, which is just y to the 10th. And we're done. So I'm going to try these out. I'm going to simplify these expressions to see how I get. So what I get, so look at A. So A is 4 squared minus 4 to the 0. Well, 4 squared is 16. 4 to the 0 is just 1. 16 minus 1 is 15. And I'm done here. B. X to the 0 cube plus 2 to the 0 times to the 5th. What does that equal to? X to the 0 is 1. Bring down the cube. Plus 2 to the 0 is 1. Bring down the 5th. 1 to the 3rd is just 1. 1 to the 5th is just 1, which is just 2. We have 3y to the 7 squared over 6x to the 5th squared. So that means we're going to do parentheses 3y 7 squared over 6x to the 5th squared. So then the 2 goes to the 3 and the y. So then we get 3 squared times y to the 7th to the 2nd power. Then we get 6 squared parentheses x to the 5th squared. So we know we're going to multiply these two exponents. So 3 squared is just 9. And then 7 times 2 is 14. 6 squared is 36. We get x to the 10. 5 times 2. This simplifies. 9 over 36 is just 1/4. So then we get y to the 14th over 4x to the 10th. And we're done here. Because 936 becomes 1/4. This reduces to 1/4. Last one, guys. Same here. So this is the only one that gets the third is over here. So the 2, the 3, and the 4. So it'll be 2 cubed a to the 3rd power b to the fourth to the third power. So we're going to multiply here, leave that there, negative 8a to the 9b squared. 2 cubed is just 8. 8 to the third times third is just 8 to the ninth. We're multiplying them. And then b12 over negative 8, 8 to the 9, b2. So then this gets a negative 1. So it would just be negative, right? These 8's cancel out. 8 to the 9's cancel out, right? 9 minus 9 is 0. So then we get negative 1. A to the 9 minus 9. B to the 12 minus 2. So then we get negative 1. A to the 0. B to the 10th. Which is just negative b to the 10th. Because a0 is 1 times negative 1. This is negative 1 here, which is invisible. Here are some practice problems for you to try out. So then we get z over 12 squared. So then we get z squared over 12 squared, which is z squared over 144. We're done there with A. B, it'll be 4x to the 6 cube. That's going to give us 4 cube x to the 6 cube. So 4 cube is 4 times 4, 16 times 4 is 64. So it'll be 6 times 3, which is 18. 64x to the 18th power. C is y 10th times y third. We're just product rule, so we're just going to add 10 plus 3, which is just y to the 13th, and we're done. Remember, quotient rule, power goes to the top and bottom. Power over power rule, multiply exponents. Product rule, add the exponents. Here is another practice problems here, guys. Simplify. So look at A. A is 8 squared minus 8 0, which is just 8 squared is 64. 8 0 is 1, so it's just 63. B is z to the 0 to the 6 plus 4 to the 0 to the 5th. So z to the 0 is 1 with the 6th power, and then 1 to the 5th power, which is just 1 plus 1, which is just 2. C, we have 5x cubed going to be squared over 15y to the 4th be squared as well. So then we get 5 squared, and then x cubed squared, 15 squared, y to the 4th squared. So 5 squared is 25. X cubed times squared is 3 times 2, which is 6. Then 15 squared, 15 times 15, I think it's 225. Yes, it is. So it'll be 225 over here. And then y to the 8th, because it's 4 times 2. Well, 25 over 225 is 1x to the 6th over 9y to the 8th. And we're done. D actually has a lot of mess actually too. So then we'll get 2z to the 8th, x to the 5th to the 4th power over negative 16z squared x to the 20th. So what happens here? So then we get 2 to the 4th, z to the 8 times 4, and then x to the 5 times 4 over negative 16z squared over x 20. Well, the top 2 to the 4th is 16. 8 times 4 is 32. X 20. over negative 16, z squared over x20. The x20s are going to cancel out. The 16s are going to cancel out. So we're left with equals negative 1 z 32 minus 2, which is just negative z to the 30th power. And we're done. Alright guys, let's push through. We have 12.2 polynomial functions and adding and subtracting polynomials. So recall that a term is a number or the product of a number and variables raised to powers. The numerical coefficient of a term, or simply the coefficient, is the numerical factor of each term. If no numerical factor appears in the term, then the coefficient is understood to be 1. Now, if the term is a number only, then it is called the constant term, or simply a constant. So make sure you're keeping track with this terminology, guys. So what that means is, like, for example, if we have 7x cubed, 7 is the numeric, this is the coefficient, and x is the variable. Now, if you have just a number, let's say you have just 3, that's just a constant by itself, a constant term, 3. All right, polynomial. So a polynomial in x is a finite sum of the term of the form axn, where a is a number and n is a whole number. So no, a polynomial is written in descending powers from left to right. A polynomial may not have negative exponents. So a polynomial, the highest exponent goes first, from left to right. So descending means from greatest to least. Greatest to least. Now, if we look at the types of polynomials, a monomial is a polynomial that has one term. A binomial has 2 terms. A trinomial is 3 terms. So those are the 3 types of polynomials that we're going to learn today, guys. So keep that in mind. So what does that look like, right? What's one term? What's 2 terms? What's 3 terms? Well, here's some examples. So some examples of monomials is ax squared negative 3z, or just 4. There's just one term. Remember, what separates the terms are pluses and minuses. So here in the binomials, you see there's only one plus sign or minus sign. So there's 2 terms in these binomials. Then we have trinomials, where you have 3 terms, or just 2 or 3 different symbols, and then more than 3. Pause here so you can make this little chart into your notebook, ladies and gentlemen. Okay, so the degree of a term. The degree of a term is the sum of the exponents on the variables contained in the term. So here we have individual terms, guys. So a is 3x squared. So the degree there of the variables, the degree is the exponent. So the degree is 2. For b, we have negative 2 cubed x to the 5th. The degree of the variable, what's the exponent of the variable, is 5. What about c? What's my degree for y? What's my exponent that we don't see? It's a 1. What about d? Remember, the degree is the sum of all the exponents of all the variables. So we have a 2, a 1, and a 3. So it'll be 2 plus 1 plus 3, which is 6. And then we have e. There's no letter there, so the degree of a constant is 0. Because it's 5x to the 0, because it's just 5 times 1, which is 5. So the degree is 0. Keep that in mind, guys, as you work through this lesson. The degree is just the sum of the exponents on the variables. Variables are the letters that we see in algebra terms. So here's practice 1. Find the degree of each term, guys. So here the degree for a is 3. For b, we have 1 plus 1, which is 2. Then C is just 1. D, degree is 2 plus 5 plus 1, which is 8. And then E, the degree is 0 because it's just a constant term. Keep that in mind. So the example 2. So the degree of a polynomial is the greatest degree of any term of the polynomial. So the highest exponent. So example 2, find a degree and tell whether the polynomial is a monomial, binomial, trinomial, or none. So look at A. A is negative 2t squared plus 3t plus 6. The highest exponent is 2. So what's my degree? My degree is going to be 2. And then how many terms do you see? 1, 2, 3. So this is a trinomial. And that's it for A. For B, my degree, the highest exponent is with the x, right? What number is there that we don't see? A 1. So that means my degree is 1 for B. How many terms do you see? 1, 2. So that means it's a binomial. Now look at the last one. What's my highest exponent? 3. So that's my degree. And there's more than 4, so it's none of these. And we're done with example 2. Practice 2. Find the degree of each polynomial and tell whether the polynomial is a monomial, binomial, trinomial, or none of these. So A is 5b squared minus 3b plus 7. The highest exponent is this 2. So my degree is 2 for A. And it's a trinomial because there's 3 terms. So trinomial. And then B is the degree. T has no exponent, so it's a 1. So my degree is 1. But there's 2 terms, so it's a binomial. And then C, my highest exponent is what? 3. So my degree is 3. But it's none of these because it's more than 3 terms. All right. So far, so good, guys. Good job on the practice. Now, here are some helpful hints. So, recall that the symbol p of x does not mean p times x. It is just a special symbol used to denote a function. So, you gotta remember, p of x does not mean p times x. It means p of x. It's a way to label a function, guys. You gotta keep that in mind. A way to keep it labeled. Example. If p of x equals 3x squared minus 2x minus 5, find the following. So A is p of 1. So p of 1 means wherever there's an x, I'm going to replace it with 1. So then it'll be 3 parentheses 1 squared minus 2 times 1 minus 5. Now use PEMDAS to simplify. 1 squared is just 1. So it'll be 3 times 1 minus 2 times 1 minus 5. Then multiply. 3 times 1 is 3. Negative 2 times 1 is negative 2. Now we add and subtract from left to right. 3 minus 2 is 1. Minus 5 is negative 4. And we're done. B is p of negative 2. So we're plugging in negative 2 for x. So it'll be 3 parentheses negative 2 squared minus 2 times negative 2 minus 5. Well, negative 2 squared is positive 4, so it'll be 3 times 4. So that's the exponent part. So now we multiply. 3 times 4 is 12. Negative 2 times negative 2 is plus 4. Now we add and subtract from left to right. 12 plus 4 is 16. Minus 5 is 11. And we're done with B. Make sure you always double check your work, guys. Plug it in and then use your PEMDAS to simplify. Here is a practice problem, guys. P of x equals negative 2x squared minus x plus 7. Find P of 1 and P of negative 4. So pause here to try it out. So P of 1. So x is replaced by 1. So it'll be negative 2 parentheses 1 squared minus parentheses 1 plus 7. 1 squared is just 1, so it'll be negative 2 times 1 minus 1 plus 7, which is just negative 2 minus 1 plus 7, which is negative 3 plus 7, which is just positive 4. Now let's look at B. B is P of negative 4, which is negative 2 parentheses negative 4 squared minus parentheses negative 4 plus 7. So then negative 4 squared is positive 16. Negative negative 4 is plus 4 plus 7. Negative 2 times 16 is negative 32. Bring down the plus 4 plus 7. So you get negative 28 plus 7, which is just negative 21. And we're done here. You simplify each polynomial by combining like terms. So A, negative 3x plus 7x, those can be combined. So negative 3x plus 7x is just 4x. B, we cannot combine x plus 3x squared because there's different terms. So we would just rewrite it in order. And we're done there. 9x cubed plus x cubed. There's a 1 here we don't see, which is just 10x cubed, and we're done. For D, we can combine the x squares. So 11x squared plus 2x squared is 13x squared. 5 minus 7 is minus 2, and we're done with D. And then E, we could add 2/5 x fourth and 1/10 x fourth. So then right there we get 2/5 plus 1/10. We'll just make this into 4/10. 2/5 is equal to 4/10. So we can combine the 1/10 and 4/10, which is 5/10 and x to the 4th. And then we'll add the x cubes, which is minus 3/6 or plus 3/6 x cubed minus x squared, which is just 1/2 x to the 4th plus 1/2 x cubed minus x squared. Now we want to just pretty much multiply the LCD, guys, of 3, 5, 10, and 6. If I remember correctly, I would say it's 60. Or actually 30. Multiply 30. And you'll get the same answer here. Here are some practice problems on combining like terms. A is negative 4y plus 2y, which is just negative 2y. B, we cannot combine them, so just write it in order from highest exponents to the bottom. C, we can combine them. 15x cubed minus x cubed is just 14x cubed. D, you can combine the a squares. 7a squared minus 3a squared is 4a squared. Minus 5 minus 7 is minus 12. And then for the E, so the LCD of 8, 6, 12, and 2 is 24. So when you multiply 24 to this, makes it a lot nicer. So the LCD is 24. Let me show you what happens when you multiply this out. So then you get 24 times 3, 8x cubed minus 24x squared plus 24 times 5 over 6 x to the fourth plus 24 times 1 over 12x cubed minus 24 times 1 over 2x fourth. So right here this becomes 3 times 3, which is just 9x cubed minus 24x squared plus 20x to the fourth plus 2x cubed minus 12x to the fourth. So then we get 8x to the fourth plus 11x cubed minus 24x squared. And then divide everything by 24. So let me see if I was right. So combine the x fourths, that'll be 3, 6, so it'll be 2, 6, 1/3. Yep, 1/3. Nice. Nice. Works out. Because then I would just divide everything by 24. Because I multiplied everything by 24. So I just divide it out. So then I get 1/3 x to the fourth plus 11/24 x cubed minus x squared, which is just what it is here. So that works out. So you multiply the 24 to get rid of the fractions, then you combine your like terms, then divide out the 24 to get your final answer. Because what we do to it, we had to undo it. So in this example, combine like terms to simplify. So notice how we have x squared and y squared, so we cannot combine those. But xy and yx is the same thing. So xy is the same thing as yx. So we can combine those two. So we get negative 9x squared plus 10xy minus 5y squared. And we're done here. This example was there to show you that yx is the same thing. This is equals, not less than. This is an equals to. So go ahead and do that here. Combine that here. So we get negative 3x squared. 9 minus 4 is just 5xy plus 5y squared. And we're done. So to add polynomials, you combine all your like terms. So here's some examples here. So you can pretty much drop the parenthesis sign. So then you'll do 7x cubed y minus xy cubed plus 11 plus 6x cubed y minus 4. So right here we can combine the constants, 11 and the 4. And we can combine the 7x cubed and the 6x cubed y. So 7 plus 6 is 13x cubed y. Then we have minus xy cubed plus 7. And we're done with A. So there's no a cubed, that's by itself. Then we have b. B is over here. And then we have the a term. And then we have the constant term. So bring down the 3a cubed. Minus b plus b cancels out. 2a plus a is 3a. Negative 5 plus 5, they cancel out. So this is our final answer. So right here, it'll tell you to add, and then it'll tell you the two polynomials. So you just kind of pretty much combine your like terms. We have the x cubic. Then we have the x squared term is by itself. Then you see the x term is not by itself. Then you see the constant term is not by itself. So just combine them, add your like terms. So there's no, so 11x cubed and x cubed, that's 12x cubed in total. There's no negative 12x squared to combine it with. X minus 10x is minus 9x. Negative 3 plus 5 is plus 2. And you're done. So let's go ahead and move on, guys. Here's this practice problem. Combine your like terms. So look at a. So you have 4y squared and y squared. And then we have 3y by itself. And then x by itself. And then the constant term by itself. So then we get a is equal to 4y squared plus y squared, which is 5y squared, right? Minus 3y plus 2x minus 9. Because we get x plus x is 2x. Negative 7 minus 2 is minus 9. So b. There's no a squared b with anything else. And then we have negative ab squared and negative 2ab squared there. And then we have 10 and then minus 10. So bring down the negative 8a squared b. And then minus 1 minus 2 is minus 3ab squared. And the 10s cancel out. And we're done. Same thing, guys. We're going to add. So highest exponent is the 7x cubed. So nothing to add there. And then we have the x squares. And then we have the x terms. And then we have the constant terms. Combine your like terms. So then we have the 7x cubed. Bring that down. The x squares cancel out. So then we have negative 6x plus 7. And we're done. So likewise, to subtract a polynomial, we add its opposite. In other words, if p and q are polynomials, then p minus q is p plus negative q. And negative q is the opposite of, or the additive inverse of the polynomial q, which is to find a negative q, we just write the opposite of each term. So the opposite of a positive is negative, the opposite of negative is positive. So subtracting polynomials, you change the signs of the terms of the polynomial being subtracted, and then you add your terms. So like right here. So this is q, so we're going to go ahead and distribute the negative, right? Which changes the signs. So bring down the original, so we have 2x cubed plus 8x squared by the 6x, right? This is p. Nothing changes. But the negative changes the sign. So positive 2x cubed becomes negative 2x cubed. Negative x squared becomes positive x squared. Positive 1 becomes negative 1. And now we combine like terms. We combine 2x cubed with negative 2x cubed. X squared with x squared. And so on. So these are going to cancel out. So then we get 8x squared plus x squared is x squared minus 6x minus 1. And we're done. So if you cannot combine anything to anything else, you just bring it down in your final answer. So there was nothing to combine the negative 6x with. There was nothing to combine the negative 1 with. So keep that in mind as you move on, alright? So here in this example, we're going to subtract 5z from the sum of these two. So we're going to add those two first. So we're going to have 8z plus 11 plus 9z minus 2. And we're going to put that in brackets. And we're going to subtract 5z minus 7 from the sum of this. So this is going to be on the right side. So we'll go ahead and add these up. So 8z plus 9z is 17z. 11 minus 2 is plus 9. Now I'm going to go ahead and subtract 5z minus 7 from here. So distribute the minus sign, right? So 5z becomes negative 5z. Negative 7 becomes plus 7. Bring down the 17z plus 9. So 17 minus 5 is 12z. 9 plus 7 is 16. And we're done. Alright, here is some practice problems, guys. Here's the first one. So don't forget we have 3x cubed minus 5x squared plus 4x. And then we're going to go ahead and distribute this minus sign to all these three terms. So x cubed becomes minus x cubed, minus x squared becomes plus x squared, plus 6 becomes minus 6. Combine your like terms. X cubed minus x cubed, so we have 2x cubed. Minus 5x squared plus x squared, so it's 1 less, minus 4x squared. Plus 4x minus 6, and we're done. So combine what you can combine and bring the rest down. So subtract this from the sum of that. So it'll be bracket parentheses 8x minus 11 plus 2x plus 5 bracket minus 3x plus 5. So combine these two guys. 8x plus 2x is 10x. Negative 11 plus 5 is negative 6. So then minus 3x plus 5. Distribute the minus sign. So then we get negative 3x minus 5. Bring down the 10x minus 6. So 10x minus 3x is 7x. Minus 6 minus 5 is negative 11. And we're done. Alright guys, and we're at 12.3, the multiplying polynomials. I'm going to go ahead and stop here guys and do another video for this. Thank you for tuning in. Rewatch any part that you need to rewatch. Thank you guys for logging on. Peace and love.